Probability trees for complicated conditional probabilities when event A influences the probability of event B. So I didn't use this language previous in this lecture, but when we say the given, the probability of B given A, we call that a conditional probability. So in complicated conditional probabilities, which we'll see in a moment, a tree diagram is helpful to visualize the relationship. So we're going to see sometimes it's called a probability tree, sometimes a tree diagram. Here we go. Diving right into practice 14. A college professor calculates that the students who attend the final review session, 90% pass the final exam. Of the students who attend the final review session, 90% pass the final. Of those who do not attend the review, only 65% pass the final. The professor estimates that 80% of the students will attend the final review session. With those numbers, sounds like a good idea for this professor with this class to go to the final review session, since 90% of the people who go pass the final. Okay. And so the professor estimates 80% will attend that review session. Okay, so again, a lot of percentages going on, and we're kind of like, all right, we're reading it, and like, okay, but what are we going to be asked? For each student, let event R be attend the review, and event P be pass the final. So if they attend the review, then that's R. If they did not attend the review, we'll call that R complement. If they pass the final, then we call that P. If they don't pass, we call it P complement. Okay, so part A is to create a probability tree. So we're going to kind of teach what that is in this example. Okay, so here's how this is going to work, and I've got it, I've got it covered up for the moment. I've turned, you can't tell, but I've turned my paper sideways because these are going to expand out lengthwise. So you might be advised to do that. Turn your paper sideways, grab a fresh sheet, because that's what I've got here. Okay, so how do we begin? So we've got these two things happening, right? Attend the review and pass the final. And based on what they describe to us, there's a certain way we're going to set this up and how it's going to unfold. So let me first show you what I've got here. Let me cover this part up at the bottom. Let me show you what I've got here on the far left, and then it's going to branch out from there. Okay. So I have the probability of R, and beneath that, the probability of R complement. And then we've got, you can see our branches are going to come off. Now, why would I begin with the probability of R and the probability of R complement versus the probability of P and P complement? So that's a great question. Hold that thought. We'll come back to it. Let's try to fill these in. Do we have information to fill these in? Do we know the probability of R? We do, right? So that's just that they attend the review. So they told us that back in the problem, the professor estimates that 80% of students will attend the review. So we can fill this in with 0.80. Can we also fill in probability of R complement? Well, a complement, right? It's the opposite of this. The people who don't go to the review, that's got to be 20%, 0.20. Okay. I also recommend fill these in with the decimals. That's going to help later. Not 80 and 20, but 0.80, 0.20. Okay. Now, where does it go from here? The next piece, let me actually kind of rotate some things. This will be, okay, that's a little bit easier. We're going to look, each of these is going to get split in half. So focusing on the probability of R. So we're thinking, okay, these are the people who went to the review. So from the people who went to the review, they might have passed the final or not passed the final. So we're going to say, okay, from this 80%, then some of them had a probability of passing the final given that they went to the review, and others the probability of not passing the final given that they went to the review. We know we're only focused on the people who went to the review. Some passed, some didn't. Okay. And let's think, before we even go down here, can we fill in either of those? Do they tell us one of these in the question? And they did. The very first sentence, the professor calculates that of the students who attend the review session, 90% pass. So he just told us this: of the people who go to the review, 90% pass. So that's 0.90. Well, then of the people who go to the review, what are the chances of not passing? Well, it's got to be 0.10, right? These two have to add up to 100% of the people who went to the review. Okay. Now let's look down here. These are the people who did not go to the review. Well, some of them passed, some of them didn't. So probability of passing given that you didn't go to the review, and the probability of not passing given that you did not go to the review. Did they tell us either one of those? And yep, that was the third number of those who do not attend the review. Okay, so we know we're in this category. Didn't attend the review. 65% pass. Okay, so our pass, 0.65. What would make that, what number would have to go here for not passing given that they didn't go to the review? They've got to add to 100%, 0.35. So this is 100% of the people who did not go to the review. And we're really off to a good start here. Let me, I'm going to slide my camera down just a bit and try and keep it. Okay. Get that right on the edge of the screen. Now it turns out there's one more branch we can do here. And it doesn't split this time, but there's more information we can get. So each of these four goes one more step. Let me just focus on the first one. Okay. So here, these are the people who went to the review and then they ended up passing. So we can find the probability of went to the review and passed. And we can find that value pretty easily. It's not told to us, but we can figure it out. How are we going to figure that out? Hey, remember back when the first formula we saw for the and, the probability of A and B? It was equal to the probability of A times the probability of B given A. Right? Probability of A and B equals the probability of A times the probability of B given A. Well, here we've got R's and P's, but it's the same thing. Probability of R and P is the probability of R times the probability of P given R. To find this number, we just need to multiply these two numbers. So it kind of like goes down the branch. So if I take 0.8 times 0.9, that's this number here. 0.8 times 0.9 is 0.72. The probability that any randomly selected student went to the review and passed is 72%. 0.72. And we can do that for each one of these. So to find this, we're always just going to look back and multiply the two numbers. 0.8 times 0.9 gives us this. Here, we've got went to the review and did not pass. Right? So we're going to take 0.8 times 0.1 and fill that in. That's 0.08. Okay. this one? Did not go to the review, but did pass. Did not go to the review and passed. 0.2 times 0.65 is 0.13. And finally, did not go to the review and did not pass. That's what we're looking at. So 0.2 times 0.35, 0.07. And we've got a breakdown. We got a lot of information. So not only can we fill in these other parts like the 0.2 and the other pieces, right? It was only this number, and this number told to us in the problem. We can fill out the others, but then we can also get so much more. We can get the probabilities of all of these ands. Boom, right there. Hey, let me ask you something. What happens when you add all of these over here? When you add all of those together, what do you get? 100%. 1.00, right? Add this to this, you get 0.8, 0.93, and then all the way up to 1 exactly. So here we see, how each category is broken down amongst all the students. 72% went to that review and passed. 7% didn't go to the review, didn't pass. That kind of all the combinations. Some people did go to the review, still didn't pass, right? I mean that, and then some people were able to pass even without it. Okay. So that's part A. Part B asks what percent of students passed the final. Okay, so that would be very difficult without this probability tree, but luckily with the probability tree we can answer part B very quickly. What percent of students just passed? Just looking at everybody in the class, how many passed? So here's what we can do. Let's try and slide this down a bit. Okay. We'll look at the two that passed. So these people here passed, and these people passed. Right? Some went to the review, some didn't, but those are the people that passed. So review and passed, no review and passed, and we can just add those together, 0.72 plus 0.13, and we get 0.85. Here they actually asked as a percentage, what percent of students? And so that's 85%, or you could answer 0.85, that'd be fine. 85% of people passed. Okay, let's stop here. We've got number 15, another probability tree, next.